Hello everyone, it's Luke here back from the Math Bros, and today we're going to be having our second video, because this is the second one, double upload today, so hopefully you all enjoy that. But we're going to be terraforming and colonizing all of the planets in the solar system. So I've done a little experiment in here, and I think I know how to do it now. I think I've worked out what I need to do, so we're going to get straight into this. So first off, obviously we'll look at good old Earth. So we'll look at its composition and its atmosphere and stuff. So as we can see here, obviously it has a very high level of Earth similarity. I don't know why it's not 100%, so if anyone can tell me why, please say, because it's Earth, it should be completely similar to itself, right? I don't know. And then life likelihood, well, it's a 97% chance of life, so very high percent chance of life happening here. So yeah, that's all good. So yeah, we also have a magnetic field here, so we need to probably insert similar settings to this to the other planets. And also we can have a look at the composition here. So yeah, mostly made of silicate here, so it's going to be a bit of a challenge to make planets like Jupiter, for instance, when the whole thing's made of hydrogen. So yeah, this is going to get pretty crazy. So let's start off with Mercury, since it is the closest planet to the sun here. So obviously we're going to need water on here, so if we let's slow down the time here, hit play, so we can get a little action. So if we just look at Mercury, for instance, it's pretty much a hotter version of our moon. Like, we can get the moon in for a little comparison here. So it's a little bigger, hotter, and maybe a little older as well. No idea, but let's put the moon away. So Mercury consists of quite a lot of iron compared to Earth does. Like, if we look, half of it almost is made of iron, so that's pretty good. So it's pretty decent, but there is no water, there's no magnetic field. Oh no, there is. No, I'm sorry, no, there isn't. No, I forgot. Yeah, Mercury does have a magnetic field, so it has a little bit of protection from the sun. So if we turn it on, we can see it is very, very small. Like, if we quickly compare to good old Earth over here, we zoom in here, press the enter bar. Look, Earth's is a lot bigger here. So yeah, we're gonna have a little bit of work on Mercury's one. So what we want to do is, well, so we don't really need to increase the size of the planet, but we're going to start off by making this a little bigger. So because we're closer to the sun, we may need a little bigger magnetic field. So I think we'll do double the size of Earth here. So Earth is 319. So let's do about 7. So 0.7. Let's do something like that maybe. Oh wait, whoops. So 0.7. So let's try that. So a lot bigger protection here. So that can make a difference. It already has half the similarity of Earth, probably due to its elements it contains. So what we'll want to do here, we'll do it a different way than usual. Instead of just adding water, like using these plus and minus options, let's do it as a different way. So if you didn't know, there is a way, or this option here called powers. You can click on that, and you can click this one called material, and then you can choose different materials. So there is 2 here which you can't do on the normal materials option. If you look back here, look, it's only 4. There used to be a 5th one which was called organics, but that disappeared for some reason. I don't know why. They're probably going to add it back in the future. And also carbon dioxide. So first off, let's add a little bit of carbon dioxide. Not too much, obviously, because this can cause greenhouse effect, which we don't want. So let's add a little bit of that. Just a tiny bit. Then we want to add some water as well. So let's start spraying Mercury with some water. So is anything happening? Oh, it's not even it. It spawned it all there. Okay. Whoops, a daisy. So let's please go back to Mercury. Come on. Damn it. So let's go back there. Let's delete all those fragments. So we're gonna have to do this very carefully here. So let's go to power again. Material. Obviously we want water, and now we just press it there. There we go. So as you can see, it is hitting Mercury at quite a high speed as well. So, and it is being taken away already. So we're gonna spray a lot of this on. So also we do need water. Let's do the carbon dioxide again. So there we go. I'm not really the best at doing this sort of stuff, but there we go. Now, what we want to do is we want to increase the albedo so it does reflect a lot more light, because it does absorb quite a lot of light, Mercury here. So let's do that. We also want to add an atmosphere. So let's get the surface pressure of 1. So if we look here, Mercury, I don't really know what I'm doing here. So 5%, or it has 5% the mass of Earth. So let's give it 5% the mass of Earth's surface pressure, maybe. Oh, actually, humans can survive on most surface pressures. Humans can't survive on low surface pressure, but they can survive a lot more on higher pressures. So let's do 0.9 ATM for now. So that gives us an atmosphere. We also want to reflect, look like, decrease the infrared emissioncy as well, so there's less greenhouse effect. Let's also bump up the little water as well. So let's do that. Now, so also let's I think we should increase the magnetic field a little more. So let's do the pole as the pole angles as well. So let's just put a few of this on here. So let's make it a little bigger. So there we go. Now it is decreasing in temperature, I believe. So let's speed up time a bit here. So there we go. And as we can see, it is decreasing in temperature, which is what we want. So hopefully it will go to something survivable. So there we go. Look at that. So we've got our water now. So it's still quite hot here, but what we want to do is we want to decrease the water a little bit, because obviously we want a bit of land. So there we go. So we've got something like this now. So there's a lot of land here, but obviously because Mercury doesn't have the most mountains and mountain ranges and stuff, so it's relatively flat. So there's no big oceans. It's really just all different land. So the most mountainous area is probably down here in the south, since there is more land here. But just look at all the craters. Mercury does look pretty cool with all that, and there is no like glowing atmosphere for some reason. It's weird. For some reason Mercury doesn't have like a glowing atmosphere like Earth does. But if we turn it off, if we go to the atmosphere option, which isn't even here for some reason, what if we try that again, reopen it maybe? Like, you can see it, there's a very dark like thing there. Like, you can see there's a very, very dark haze. But if you just look right about there, if you look carefully, there's like a brown disc around the planet. And if I go here, turn it on and off, you can see it gets brighter and darker. So it's a very strange atmosphere. You can't really see it from behind, sadly. But yeah, there is an atmosphere that you can't really see. Look, if I turn it on and off, it gets brighter and darker. It's a very like brownish red colour. But anyways, let's keep an eye out on the temperature here, and will it be colonizable? So we want to make it reflect a little more light, so the temperature will decrease even more. So it is reflecting 85% of the light it's receiving right now. And there we go. So it's in Earth-like temperatures now. So will it get too cold or will it stay warm? So let's decrease the water again, just so we get a little bit more land. So there we go. Something like that looks good. Got more land than ocean here. So actually, let's do it one more time. So there we go. Oh no, that's definitely too much. Okay. So we want to do it with this option here. Oh, that was a mistake. Whoops. I wasn't going to press that. So let's I want to press this minus button here. This decreases it slow. So there we go. This is what I want. So let's cool this down. So this will probably be a longer video than today as well. Usually, normal, probably normal sort of time, 20 to 30 minutes. Because yeah, this stuff does get quite hard to do and complicated. There's a lot of stuff you need to do here. So let's cool this down, or not cool it down. Decrease the mass of the water percentage overall. So there we go. That's something that looks good. So we've got a big ocean here, and we've got more land in the south. Sort of like Mars, actually. Mars has a lot more high land in the south rather than it does in the north. So there we go. So we've got plenty of like continents here, North Pole and South Pole. There won't be any snow here because there's no option to add climate or anything. So there we go. So that is now at a stable 24 or 20, around 20 degrees Celsius. So there we go. We're not losing any mass here. Like, all of the mass is pretty much staying the same. So that's good. So we've got a pretty much stable Mercury here. So that's colonized. So let's make it reflect a little more. So 86. So just so it goes below 30. We don't want it much higher than 30. So there we go. So it'd be quite a warm paradise here. So if you want to get like a tan or anything, here's the place to go. So there we are. Looks pretty sweet. So let's decrease it a little more. Just want a little more land so it looks perfect. And I'll also be saving this simulation after I finish the video. So if you ever want a request where we go back to this video for another like idea, I can always have this simulation ready to go. I'll probably call it Colonized System or something, I don't know. So now let's quickly go to Venus, and Venus isn't that hard, because what you want to do is, instead of adding atmosphere and things like that, what we want to do is we want to remove atmosphere. So right now Venus has 90.7 times the surface pressure of Earth. So that's way too much. That's what gives it its greenhouse effect, because if you look right here, it reflects 88% of the light it receives, but that 12% it does receive of light completely makes it completely too hot, and it has a lot of infrared emission as well. So what we want to do is we want to put this to about 0.75, so 75%. So that's not even one whole. We want to make it less than Earth. And now the temperature is going to completely drop. We also want it to make it so it does absorb more light, but it won't cause too much problems. So while that's cooling down, we can also remove the atmosphere. So this is what Venus looks like underneath the clouds, because obviously this is all the clouds and atmosphere. That's what it looks like from space. But if you X-ray it, this is what Venus actually looks like. So very, very like deserty sort of colour here. Even though it's not really a desert, this is all just probably hard rock. And from what I know as well, Venus is like Mars. It has no active volcanoes, I don't think. So yeah, if anyone can clarify that, that'd be good as well. But I'm pretty sure Venus does not have any not any active volcanoes. So it's not like Earth, where it's got like active volcanoes and stuff like that. This is a very dead planet. So that's why it doesn't really have a magnetic field, because it's not geologically active. But for the sake of the video, we're going to give it a bit of a magnetic field. So let's Earth was 0.3, so let's do 0.4. Let's just do that. It's a little stronger than Earth's, but it is closer. So it does need to be protected from the radiation and stuff from the sun. So there we go. Let's do that. And also, if there's anything I'm doing wrong here, guys, please tell me. And also, while I'm thinking about it, let's go back to Mercury. So it has a 82% chance of life now, so that, or similarity to Earth. And then it has a 16% chance of life to evolve. So that's pretty cool. But anyways, let's go back to Venus now. And let's speed up time a lot more so we can check it out. And also, hopefully, Mercury is staying blue with its water, which it looks like it is. So Mercury is now properly stable. Like, that looks all good. So there we are. So now, if we check Venus again, so Venus is cooling down, which is good. So, oh no, it is heating up again. Okay, we need to be careful. Let's just turn down the infrared emission a bit. Let's also make it reflect a little more light as well, so it does that. So we still have the clouds, remember, so even with the cloud, it would reflect quite a lot of light. So there we go. So the temperature's decreasing nicely. Now, this is the good stuff. Now we want to add the water in. So, oh no, I don't want to do on that one. So, material, let's get the water ready to go. Let's also decrease time as well. So there we go. So start spraying water on Venus. So there we go. So we're spraying a lot of here, and there we go. Let's also spray a bit of, let's do organics, we don't really do that much. All the green, we don't see much green in this game. Carbon dioxide as well, just have a little bit, not too much, obviously, so let's do that. Spray a little more on, and that's it. So we're all good. Oh, it's about to hit, and there we go. So there we are, and let's delete those green ones, we don't want them. So, now, if we look at the composition here, we've got a decent amount of water, and if you look carefully, there is a green area which has appeared on Venus. So there's that little green line. That is the organics I just threw on it. Honestly, I don't really get the purpose of them. So if anyone will tell me what the purpose of organics is, please say. Because I don't really know what elements it consists of. Yeah, I may be a bit of a dum-dum on this, but yeah, I don't really do composition of stuff. Not really the biggest fan of elements and all that sort of stuff. But I have quite a decent amount of knowledge on it. Whoa, look at that massive hole there. But there we go. It's all getting buried by the water now. So let's decrease the water a bit. So there we are. And Venus is looking pretty cool now, so it's more of a yellowy sort of world. I can't change the colour of it, sadly, but yeah, that's that. So, looks pretty cool. And then if we add the atmosphere back on as well, you can't see the surface at all, so we're going to leave the atmosphere off for now. And hopefully, if we speed up time a lot more, this planet will stay the way it is. So it's staying about 50 degrees, that's quite a lot too hot, right? So let's make it reflect a little more light. So it's cooling down, because we want it below 30 degrees, but above 15. So there we go. So make it reflect a little more. Okay, that's too cold. Okay, so there we are. So 81% of the light it receives, it reflects. So there we are. So looking pretty good. We still have that crater there, but when I save the simulation, that crater will disappear. So we're all good. So there we go. We've got our custom Venus now, which is pretty sweet. So yeah, it looks good. Also, we can, yeah, we'll leave the clouds off. Wait, display mode. Can we do anything here? Yeah, these won't do anything. They look pretty cool though. So you can see the dark red is the highest points in the land, I believe. And then hologram, that's a pretty cool. It's like an X-rayed sort of thing. It's pretty sweet, but yeah, I'm just going to keep it on the regular one for now. Also, if you didn't know, with stars, a little off topic here, stars also have different appearance modes. You can have a little fun with these two. So if we zoom in on the sun here, it's a different sort of colour. It looks pretty cool. And if we go to this one here, this one's pretty cool. Red stars, that looks cool, but yeah, I still like it on the good old default. Anyways, obviously Earth is already habitable. 30 degrees, that's a little too hot. I don't know why it's doing that. Let's put the climate on, maybe that'll sort it out. And then Venus, okay. And now here's a good one, Mars. A lot of people have done Mars on YouTube, I think. So let's do it as well. So here we are. So Mars is a very dead world as well. Not much really goes on here, but let's start off by giving it a bit of a magnetic field. So it's yeah, so let's do 0.35, maybe. It's a little higher than Earth's. So obviously Mars is smaller, it may need it. So there we go, got our little protection now, which is pretty cool. Now, I don't know if I do anything with these options here. I don't know. Let's add a little number in just in case. But yeah, I don't really get the magnetic field option here. So it's already 75% similar to Earth. So that's pretty cool there. So that's pretty nice stuff. But also, let's check Venus's similarity quick as well. I keep on forgetting. So Venus's similarity to Earth is 9.78. Okay, that's very high. So okay, it's a higher similarity to the Earth than Earth is itself. Look, if we look, 0.978, and then Earth is only 0.962. So Venus is more like Earth than Earth is apparently. So that's pretty sweet. And it has a very 25% chance of life on it as well, so that's pretty cool. So higher chance than Mercury actually. Well, it's a little bigger as well, so there's more chance, like more land to stuff to evolve, I guess. But anyways, back onto Mars. So we can remove the atmosphere. It's a very brownish sort of red colour. The atmosphere makes it look more red than it actually is from, like, without it, obviously. So there we go. Now, what we want to do with Mars is we want to increase its atmosphere here. So if we look at its surface pressure, yeah, Earth is 1.0, but this is 0.00709, so very, very small percent of life here, so, or not life, atmosphere. So let's give it 1.5, so it's a lot more surface pressure than it usually has, and hopefully the temperature will start to increase now. So, okay, it is, okay, that's good. So let's speed up time a lot more. We'll keep an eye on Venus and Mercury, see if they're doing good as well. So let's have a look, keep an eye. So Venus is doing good, and then obviously Mercury is all good as well. A little colder now. Alright, cool. Okay, Mars is getting too hot. This isn't good. So let's make it reflect a little more light here. Well, the greenhouse effect is very high. That's not too good. Okay, we may have done a little too much. Let's do 1.25 now. Alright, so hopefully that will cool it down. It's still increasing. Okay. Okay, we've done too much surface pressure. Let's do 1.1 then. So a little higher than Earth. Okay, there we go. Now it's decreasing. Let's also do that. Or we can do enable climate as well. Is that going to do anything? I have no idea. Was that going to... Yeah, I don't really... Okay, there we go. Okay, now it's getting too cold. No, please don't do that. Okay, so let's do 1.3 again. We need it to heat up. Okay, I don't know what's up with the climate there. See, the climate option on Mars is a little buggy, I think, but... Yeah, that's that. So let's cool this down again until it starts or stops increasing. We don't want it increasing. In fact, let's make it a little weaker than Earth's atmosphere. It is that's why. It is a smaller planet, so it doesn't need as much atmosphere or surface pressure, I don't think. So, okay, I think that should be good. Yeah, and obviously, if I'm doing anything wrong, guys, please tell me, because I can always come back and do a part 2 just to, like, do everything and make sure it's all correct. So, yeah, that's that. Anyways... Let's start adding the water on now. So let's go to power and then go to material again. And let's add a bit of carbon dioxide on as well. Bit of no, don't hydrogen, definitely not hydrogen. Okay, organics, tiny little bit of that, and water. Don't know why it keeps on making. It didn't used to make all these explosion marks. It's kind of annoying. So it definitely didn't used to do that. It's really irritating there. Wait, can we change it? Oh yeah, we can turn off impact marks. So that's good. We'll leave that off now. Alright, so Mars looks very, very pretty with its water and its like red atmosphere or pinky atmosphere as well. It's pretty nice. So check out the composition here as well. Not much iron compared to silicate here. Silicate pretty much owns Mars, so got too much water though, that's for sure. So let's cool it or turn it off. What's the word? Decrease water or the amount of water. So yeah, if you want the surface to be visible, you're going to want it to be about 0.2, so about 200. If you look at it here, not including the 0. So let's do it a little more. Come on, a little more, just a little more. There we go. So we can see the volcanoes of Mars are now sticking out. So you've got like volcanoes like Olympus Mons, which is the biggest one. We've got the other 2 or the other 4. There should be 3 actually. I think the 3rd one is there. If you pause it, decrease a little more. Any second now, is it going to appear? Yeah, see there's 1, 2, 3, 4. So yeah, that's all that. So they're the volcanoes of Mars. They're the highest points on Mars. So that's pretty cool. Okay, there we go. There it is. Alright, anyways, let's slow down time a little more. And Earth already has a 23-hour day as well. So actually, if we want to go back to Venus and make its day a little shorter, because yeah, Venus's year is actually quicker than its day, if you didn't know. It goes around the sun quicker than it rotates one, so that's pretty cool. Okay, actually, we're going to need to make this a lot less, actually, so let's do it again. Come on, please. When is it going to hurry up? Any second now. Okay, the water's gone pretty crazy here. Come on. Oh, I know what I did wrong. Okay, there we go. Now it should be appearing. Yeah, there we go. Actually, I want to quickly reload this as well so that impact mark disappears, because that's getting really annoying. So let's quickly save it and then reopen it as well. And hopefully it will update all of the planets to make sure they're all going well. So, come on, where is it? There's a lot of simulations here. So there we go. Okay, so let's quickly have a quick check up on Mercury. So Mercury has frozen. That's just a common glitch in the game. So let's put it to 0. Venus, we can also put that on 0. And Earth as well. Oh no, Earth is fine, but let's put it on 0 anyway. And let's turn off the climate, because the climate seems to be messing it up a bit. So there we go. Now Mars, let's also put that to 0 so it starts warming up. And as we can see, it's quite a bit of an ice ball right now. So we want to decrease the water again. So let's do that. And there we go. So as we can see, the whole north is all ice, and then the south is land. And also we've got this massive lake here. That's crazy. That's huge. We've got that is not a lake. As you can see, it is linked to the sea. There's probably a passage you can get through there. Wait, is there? Oh no, it is blocked off. Oh no, it's not. If you look on this part here where my mouse is, that is blocked off. But if you look right about there where my mouse is, that is touching this piece of land here. But this main ocean here connects to the lake through here. So yeah, that's that. We've also got this giant like gorge on Mars. That's all completely full of water now. So let's put it on minutes. Actually, no, a little more. Okay, so there we go. So we've got the volcanoes there. They're massive islands themselves. And there we go, it's just going to start going blue. And as we can see, we've got a very nice looking planet now. And hopefully we could one day replicate this in the future, because there have been like theories that we could one day colonize Mars and Venus actually. Don't know about Mercury, but Mars and Venus is a possible chance. We just need to create water with hydrogen and stuff like that. So we just need a hydrogen. Because if anyone saw the film The Martian, pretty cool film, I recommend you go check it out. But if anyone saw that, the guy in the the film, he actually managed to make like potatoes. He could grow it, and from what I've seen like on the internet, apparently that could actually be redone in real life. So there is a possibility we could get we could be able to grow stuff on Mars one day and actually have like water and stuff. Don't know about a whole ocean like this, because this is a lot of water, but still, if we could like try and create water with hydrogen and oxygen, like we could get something going there. So it'd be pretty cool. But anyways, so we're at a nice 7 degrees, 8 degrees. Okay, so we want to keep an eye on that temperature, and let's speed it up a lot more. And how high will Mars be going? Okay. Ooh, so it gets cold and then hot again. So the seasons on Mars are a little different. So if we look at the orbit, where it is right now is further than it is over on this side. So the seasons on Mars are a little strange. So we're going to have we need a little more atmosphere to replicate this. So let's increase the atmosphere mass up again. So yeah, we want it. Wait, where is it? Oh, surface pressure, I should say. So we want to increase this a little more. So let's do about something like this. We want it to stay in positive degrees at all times. So it may get a little too hot at some point, but we do need it to stay with water to keep like things alive. So yeah, that's that. So now let's keep an eye out. So let's zoom out again. Then now let's have a look. So the hottest point, it goes up to about 48, it looked there. And then when it goes to the cold point, it goes to 20. But then is it going to stay at about 40? So it looks like, yeah, the limit is 40 degrees. And the coldest point is 20. So, yeah, that's livable, I think. So let's cool it down a little more, actually. Okay, so we want the cold point to be about 15. Okay. Okay, I think that's stable. I think we could live there. I think it may be a little hot because the summer is obviously on this side of this side of the sun. That's definitely the hot season. So, yeah, that would be that. So it's 39.3. Like, that is very hot. But then if we put it down again, like, then it goes cold. Okay, in fact, actually, I think I am actually going to have a winter. So let's put it down to 0.2 again. So 0.2, yeah, something like that, 2.8. So we have our summer there, then the winter here. So it goes -12. So it's kind of like Canada. So if you don't know Canada, I think it gets very, very cold in the winter there, because it's obviously quite high up as well. It's above the USA, and places in the USA can be very cold. Like I've been to New York and Washington before. I'm talking about the city, not the state. And yeah, it was freezing when I went, because it was in February, and obviously that's the winter for America, or anyone above the equator in the north. So it was winter. The air was freezing cold. Like I can't explain it enough. Like it was so cold. Even wearing like heavy layers, it was still very cold. So there we go. So it goes to about 20 at the highest, and it goes into the minuses for a very brief time. Then it goes to 25 again. So there we go. That's good. Then Earth. You see, Earth is going above 25 as well. So if we can live on Earth, we can live on Mars with the same temperature. So looks good. Now I'm not going to do Ceres or Vesta, because they are typically not planets. So I'm going to leave them out, or leave them out for now. So if you want me to do them in another episode, please say. And now we get onto the good stuff. So we're going to do the gas giants now. Yeah, I probably could do Ceres, but yeah, if you want me to do an episode on that, just say. But I don't know about Vesta, because it is a very small object. But yeah, Ceres is a possible. So if you want me to do that, just say. I don't know why I've said it 3 times. Okay, I'm weird. Right, so now with Jupiter, we're going to do it to all the gas giants at once, actually. But we are going to remove the hydrogen. So I'm going to put it all the way down to 0, because we do not want that. So we're going to do it with Saturn as well, Uranus as well, and then Neptune. So if you look there as well, Uranus and Neptune have a lot more water and less hydrogen. And then Neptune, let's do that. And also we're doing Planet 9, since it is a planet. We don't know if it's real, but it still is a planet. we think. So we're going to do that as well. So there we are. So if we go down to Jupiter now, this is all that's left. So this is the core of Jupiter. This is the rocky part in the middle. So there we go. So it's still the most massive. Still got all of its mass. It's just it's now in silicate and iron. So we're going to add a little bit of iron as well. About, let's do 11% or 14% of iron. Also gonna, I don't like this like texture as well, so we're gonna quickly add the atmosphere back and then remove it. So I don't like this this line here. It's weird. Can we? There we go. It's gone now. Alright, cool. Yeah, if you add hydrogen and remove it, the surface changes. If you didn't know, so it's pretty cool. Actually, I don't like this one either. Let's do it again. Okay, there we go. We'll live with that one. Alright, cool. So we've got our new Jupiter now, and obviously it's very, very cold here. And obviously, because it's a bigger planet, we're going to want a lot of surface pressure here. So let's close it and then reopen it. Oh, I didn't need to do that. I'd already done it. All right. So we got these. Because if you do it with, if you've just removed the hydrogen for the first time, this option of the atmosphere is not here. Right. Anyways, let's go to ATM. And since it is 5 times further away than Earth, let's give it 5 times the pressure of Earth. So it has 5 times the atmosphere, I think. So there we go. So we can have a look here. Will this do anything? Will it heat up? So let's have a look. Okay, it still gets cold. So it's increase infrared efficiency to max. Then make the atmosphere even bigger. So let's do 10 now. We want it to continually go, and also, or it already has a magnetic field, so we don't need to play around with that. So 15 maybe. Yeah, this might take a while. So let's do 20. We need it to go in positive. Let's decrease the albedo even more. Okay, it's still getting colder. Okay, this is going to be quite hard. So about 40. Still getting colder. Okay, 50. Still getting colder again. Let's put it as its closest point to the sun as well. So here. This is the closest point in its orbit to the sun, so let's try this. 0 degrees, still getting colder. Okay, this is quite hard. We could put another, like a moon close, so we could try and get a bit of tidal heat into it. So let's get Ganymede and put it really close, so something like this maybe? Will it warm it up? No, it's still getting cold. It's getting torn up as well. Okay, we don't want that, so let's remove that and then delete Ganymede. Okay, I don't know what to do. We could try, I don't know, 70? Or set 70. Is that going to warm it up? Still getting colder. Okay, so... Okay, not 700. No. Okay, 100? 150. Okay, 700. Okay, now it works, doesn't it? 700 times the pressure of Earth. I think that's a little too crazy, but... Is it actually going to work? So it is getting in positive, but how hot will it go? Okay, it's getting way too hot now, so... Let's half that to do 350. Will it... Okay, it's cooling down again. Okay, this looks good. So let's do 330. Okay, so that's Earth-like temperatures right here. So how hot will it go? So let's do a whole year on Jupiter. So let's go all the way around. So it will... Okay, in the summer it looks like it'll get to 30, and then in the winter it goes to 15. So okay, that's good. Oh, look at all the planets moving. That's cool. Even Planet 9 said they were moving. Wow, okay. And let's check on the inner solar systems. Everyone's doing good. So Venus, let's quickly remove the cloud. So Venus is doing good. Mercury as well. Earth, obviously. Mars. Okay, cool. So now back on Jupiter. So we have got something going here. So we need a lot of surface pressure if we're going to get this going properly. So look at that greenhouse effect. And it's so far away, it doesn't really increase. If we had this atmosphere on Earth, Earth's surface would melt. It would get very hot. And then on Venus, it'd be even worse. So we're not even going to try that. But if you want me to do it in another episode as well, if you want me to make the atmosphere, like, or the surface pressure on Earth really, really high, yeah, leave it down below and I'll do it. So, yeah, that's that. Or maybe I'll do it any day when I haven't got any ideas or something. I don't know. I'll run out of ideas. I don't know. Anyway, I do like hearing suggestions. So, let's just see about 0.6. What am I doing? 0.6. Okay, now, let's add the water on. And it also has that dark atmosphere like Mercury as well. If you see here, it has that very like brown looking atmosphere. If we add and remove, as you can see, it has a very like brown tint to it. So it's very, very strange. So let's get in the material ready. Let's slow down time, hit play. Let's get the water ready and let's shoot some water on it. So there we go. Just do it little bits at once. We don't want to do it too much. Okay, there we go. We've got some water or frozen lakes appearing now on Jupiter. So there we go. A little bit more, and there we go. So we've got a bit of an ocean going now. So let's do a tiny little bit more. Okay, there we are. So there's a very lot of very strange here. Let's refresh it again. So let's add hydrogen and remove it. Get some different looks here. Okay, that looks different. Okay, I like that. Alright, cool. So now what I want to do is, let's do another whole year on Jupiter so we can check, see if it's all doing good. So let's do another year on Jupiter. So let's speed up time again. Let's go all the way around. So there we go. Okay, we've done a year. Okay, so let's have a look. So we've got a lot of water on one side, or a lot of water in the south, and then more land in the north here. Okay, cool. So what we want to do is, since that's working well, and if we have a look, it's got a life likelihood and an earth similarity. That means plants and stuff would begin to grow. So that means, okay, we can't do it, dang it. I was going to add like different surface color and stuff like that. So that does kind of suck, but I already can't do anything about that. Sorry, guys. But I would change the colour of the surface and stuff. It may work with Planet 9, but since it is a custom object after all, but all of the other planets which spawn in when you load a simulation up, like you can't change the colours of them even though they are planets. In fact, we could try, actually, so let's save the simulation again, and then reopen it. Maybe we'll be able to change it now. So let's load it up. There's a lot of old thumbnails here as well. I just don't delete them. I'm weird. Alright, so we're back on here. Let's go straight to Jupiter. Now, can we change the colour? Oh, yes, we can! Okay, so just, you got to reload the simulation if you want to change the colour. And I'm assuming that works with the sun as well. So if you turn the sun to a planet and reload the simulation, you should be able to change the colour of the planet. So, okay, there we go. So, like I was saying, now it's similar to Earth, life would start to begin to grow. So, that means green plants and stuff will begin to appear. Okay, why is it getting cold? Okay, that's just a reload simulation. Okay, there we go. So, it'll start warming up. Oh, we've got to do it with all of them now. Dang it. Alright, so, let's go to Venus. In fact, let's just do a year on it. If we just do another year, let's speed up time. So, there we go. If we just do another whole year, like that, or a Jupiter year anyway, now they should all be warmed up. So let's quickly check. So Earth is warmed up, Mercury, Venus, okay, Mars. Alright, cool. So now if we go back, so Jupiter's 24 degrees, so it's a little warmer than the other ones, but it is still further away. Alright, so if we look very, very carefully, we've got green areas starting to appear. Now let's do the mid elevation so we can see. There we go. So let's make it like a jungle sort of planet. Let's do like the darker green, like the very like limey, or not lime, like just a dark green in general. So there we go. And now we've got the white part. So let's make that, let's do a yellow. I think that looks, and then a little more green. Okay, there we are. So there we go. We've got our Jupiter now. So we've got a colonized Jupiter. So 27 degrees, a little warm, I should say. So there we are. Looks good. So I think that's a good job there. Job well done. So got a very jungle sort of Jupiter here. Jungle Jupiter. JJ. Alright. There we are. So let's go out of Jupiter. So that's a job well done. Still has one mass of Jupiter as well. So the mass has not changed. It's just the elements have. Now let's go to Saturn. So Saturn seems to have a lot more water than Jupiter does already. So let's decrease that straight away to put it to a very low thing here. So let's do there. Okay. Let's decrease a little more so we get a bit of a surface below. Okay, there we are. So, and also let's start off with like dull colours. Let's start off with like white and stuff. It's very cold here still. So, if Jupiter has a surface pressure of, what was it? A surface pressure of 330, and Saturn's like double the distance, I'm saying we've got to do 660 surface pressures of Earth here to make this work. So let's do this. Now put it back to 0, and it starts warming up. Okay, cool. Let's increase the infrared as well. Alright, let's leave it at 91. Alright, now let's speed up again. Let's see how hot Saturn will get. So, yeah, looks good. So, and there we go. We've already done it with Saturn. That was quick. And also, we don't need to touch the magnetic field since Saturn already has one, I believe. So, yeah, there we go. A massive one for Saturn there. So, also, they used to be gas giants, and they still have the mass of what they used to have as well. So, yeah, not much has changed. Yeah, 0.299, still the same. So, very, very fast and quick one with Saturn there. So, there we go. So, now we can get to the options on Saturn. Remember, Saturn is still on its side here. It's not straight, like, the North Pole is here. So, the North Pole is in darkness right now. Because if we do a whole, or if we speed up time a lot more, let's put it on this mode as well. So, the North Pole is where this line is sticking out, and then the South is there. So, the South is permanently in daylight, and the North is in darkness. But when we go around the Sun, the North will now be in the sunlight, and then the South will be in the dark. It's very cool. It's a little more tilted than Earth is, I believe. So, yeah, pretty interesting fact if you didn't know. So, yeah, for a Saturn year, half of it is in the darkness, and then the other half, the North or South, is in the light. So, pretty cool. So, let's make Saturn a very, very nice place. So, let's give it beaches and stuff. So, actually, let's do the green. Looks good. Still looks too much like a jungle, though. So, let's do bit of yellow there to look more like a beach. And no, actually no, yellow needs to be the bottom colour, and then these colours need to be darker greens. I think. Yeah, there we go. I've got a bit of like desert there. A little too like green, I'd just say though. So can make it a little lighter. In fact, let's make actually no. Can make it a little more orange maybe. So without the atmosphere, it doesn't look as pretty as well, which kind of sucks. So let's give it good try. Actually, let's have like some cold mountains. So let's have white, like little white areas. So these are the highest points. They're the coldest like mountains, the mountain ranges. Now, they're a bit lower down. Let's have more of a greenish sort of colour. So, actually, no, this should be yellow, I think. So, this one here, this would be like deserts and stuff. So, there's the sand. And then the bottom colour should be green as well. Oh, no, wait, what am I saying? So, that should be yellow. This colour should be green. There we go. So, we've got the mountains in the middle. Then we've got like, the green forest. And then we've got like more of a desert sort of look here. I think that's the colour of sand. So, we've got like, it's more of like a tropical sort of planet now. So we've got like the mountains, yeah, they've got the forest, and then we've got like the beaches and stuff with like tiny little forests in them. So yeah, we've got like a tropical Saturn now. So we've got jungle Jupiter, tropical Saturn. Oh, why did I come up with these silly names? And now let's go to Uranus. So yeah, look at that, looks cool. Oh, Mars is frozen. Okay, let's have a quick check up on Mars. What's up with you? So if we check here, 0, is it going to increase? Okay, it's getting cold. Okay, we've got a problem with Mars. What's going on? So let's make it absorb a little more light. Yeah, there we go. Just have to change its albedo a bit for some reason. Alright, so let's put it up to 10 just so it looks blue. There we go. So now, if we look at the options here, they're all nice. Okay, Venus as well. Let's remove the atmosphere again, just to make it look good. 23 degrees, that's pretty cool. Alright, now, there we go. So, all nice blue. Look at that. Jungle Jupiter. Tropical Saturn. Now, Uranus. I think I'm going to make this one more of a mountain range. And Uranus is, remember, is on its side as well, so the North Pole is here, and then the South is there. And obviously, when it goes around the Sun, half of the year the North is in the Sun, then half of the year the South is in the Sun. So now the South is in the Sun, North is in darkness. Like, very, very cool setup here. So, now, what we want to do is, let's slow down time, and let's do this. So, Uranus is now double the distance of what Saturn is now. So we want to go to Saturn again. Saturn is 660. So let's make this about 1300. Or 1300 ATM. So this is massive amounts of pressure here. I don't know if this isn't really realistic, I don't think, but it works for me. So there we go. So now it's put to 0, and there we go. Temperature is increasing. So let's now do a whole year on Uranus, and let's see how hot it does get. So, okay, getting way, way too hot. Okay, let's do 1100, so like that. Okay, still too hot. Okay, good to know. So 900. Let's make it reflect a little more light as well. Okay, looks good. So 22 degrees. Let's now do this. We'll make it more of a mountainous sort of planet, so there'll be less water and it'll be a little colder than the other planets. So let's do something like this, maybe. Yeah. So it's below 10 degrees at all times, and it does get cold. So this is its winter here, where it gets blue, like goes white like that. So looks pretty cool. In fact, actually, let's make it a little less. We want it to stay in the positive. So yeah, it gets to about 1 degree at that point there. And let's check it again. So it goes cold for a very, very brief time there, but we'll leave it like that. I think that's cool. So actually, no, that's going to bother me if one of them is not blue. So let's do that. Okay, now let's try. So it's going to go around. Okay, it's always above now. So the hottest point looks like it gets to 15, 16, and then it's okay, 16 degrees. So that's not very hot at all. That's like the sort of temperatures we get in the UK in the good day, I think. So yeah, that's that. Now let's go and obviously remove some water. So there's a lot too much water here because this used to be an ice giant. So there's a lot of water it contains. So let's remove this. We don't want too much water here. So let's increase it up again. So a little bit. All right, now we don't want much water since it will be a mountainous sort of planet. So let's slow down time again. We can't do anything about the brown atmosphere. I am sorry for that, but we're not really going to do anything like that. So let's increase again. Okay, so we don't want too much. So we've got a bit of a... Okay, it's interesting. So where is that black or the darkest part? So this part here, this looked like the most promising for a lake. So let's slow down time a little more. So let's look on this point here. It's so annoying the way Uranus rotates because it keeps them going dark like that. Actually, so okay, okay, here we go. So let's add water again. So let's continue pressing that. Okay, too much. Okay, there we go, something like that. So we've got a big lake in the middle here. That's like the most point of ocean. So yeah, we'll leave it like that. So there's a lot of land here, and now because it'd be a mountain planet, it will be very, very cold since there'll be a lot of snow here. So And then we'll see have a little. We'll have some green, obviously, because yeah, that's that. So these will be the lower points in the land, and then the rest of it, all the white parts, will be mountains and stuff like that. So there we go. So it's looking very, very peculiar, but I think it's unique, right? Like, you want to make it look unique. So let's do a little. Let's do something like that. I think that looks very cool. So got a bit of forest here, and then it all goes bad. So actually, we won't have it like really, really bright green. We'll have it more of a dark green, since, like, you know, like if you go to a forest in, like, say, a cold place, it's usually like dark spruce sort of trees, like spruce trees. So like cold places always have spruce trees or conifers or like evergreen trees. So they're usually dark green, not like light green. So put it to a very dark green like that. That looks good. I think that looks really nice. So let's do this, and then there we go. So we got our colonized Uranus. Whoa, 34 degrees. Whoa, whoa, whoa. That's not right. Because remember, even if it's 34 degrees, this is just a surface temperature. It's not like a temperature for the whole planet. So different points would be different temperatures. So yeah, you got to keep that in mind. So let's speed up again right here, like this, and let's see what its temperature will turn to. So let's speed up again. Let's go another whole uranium year now. So okay, it's getting very, very hot now. We don't want that. I don't know why it's doing that. So we want it to go cold again. So okay, 9, 8, 7. Okay, 7 degrees is the coldest, and then the hottest is 20. Okay, I can work with that. So now we can cool it down again, and I'll slow down time, and then we can look. So there we go. Got our custom Uranus colonized now, so it looks pretty cool. I love the color mode. The color mode makes it look a lot cooler as well. So we've got a giant lake in the middle. I wouldn't really call it an ocean, but we've got a massive lake here, and then we've got other pockets of water around the whole planet as well. So very, very cool. And also you got to remember, some parts are in permanent darkness. So if you want to have a quick look at the entire planet, put it on flashlight mode, and there you go. So it'll be turning like this. So this point here will be in darkness a lot, and then this point over here as well. So yeah, pretty cool. So let's put it back on realistic mode, and there we go. Now the last planet, or not second to last planet, now we've got Neptune. So my favourite planet, and I think I love Neptune because of its colour as well, not just because of like how cool it is with like its wind speeds and stuff like that. So we're going to make it more of an ocean planet. So let's start off by making it. Okay, let's do go to ATM. Let's do 1200 here. So let's see what it will start off with here. So let's do 0 degrees. So it's warming up already, which is pretty cool. Now let's see how hot it will get, or how cold it will get. So I won't be doing Pluto for this episode either, since we typically don't know it as a planet sadly anymore. So yeah, that's that. That does suck. So let's increase it a little more. Okay, 20 degrees. Will it? If I'm good with it, stays at 20. So okay, so Neptune's more of it stays more of the same temperature. And, well, it's a little laggy at this sort of speed. Look at all the lines and stuff. How many Mercury years have happened in this time? We're doing 2 years a second right now. Like, Mercury's just zooming around the sun. Okay, we've definitely got to slow this down. Alright, so let's do, let's go back to 3 hours. So, yeah, that's that. Yeah, and I think I will make a part 2 to this. We will get it all done. But any tweaks you guys want me to do with this, I also think I may change like the day and night cycles and stuff like that, because 16 hours a day, I think that's fine. But when you go to Venus and Mercury, they got a lot longer days. We need to change that. So yeah, that's that. So yeah, I may make a part 2. So should I make a part 2? Please tell me, because obviously I'm not going to do Pluto, Eris, Sedna as well, and obviously Ceres and all that. So yeah, if you want me to do like a dwarf planet like part 2, yeah, please tell me. So anyways, let's go back to Neptune now. So we want it to decrease the water a lot, obviously, because it's an ice giant as well. So a lot of ice and methane and stuff. So there we go. So it's definitely more of a ocean world here, but I like it like that. Neptune's always been a cool like bluish colour. So it's had a lot of it's had some yellow in, because that's going to be like the beaches. So we've got the sand. Then we'll also have some green. Obviously, we want some land, and then the white. What colour should I do this? Let's do white again. We'll have a bit of like mountains or like colder points there, a little bit of snow. I don't know. Yeah, I think that looks cool. So actually, nah. Okay, so let's do a bit of like that. I think that looks pretty cool. So change the color again. Let's have a look. So the beaches will be a very pale sort of yellowy color, like the color of sand. Let's also make this green a little more. Let's have a little bit of a darker green, so we can really tell the difference between the beaches and the land and stuff. So there we go. So we've got our ocean world of Neptune now, which looks pretty cool. 34, okay, a little too hot. Let's make it reflect a little more light. Okay, let's see a whole year on Neptune now. So it's about 200 Earth years 1 year on Neptune. 250, I want to say. Okay, definitely too hot there. So let's cool it down with the reflection light more. So let's speed this up. So let's do a whole year on Neptune, or do a few years. So still staying in the 30s. So let's make it a lot colder. So, okay, so 30... 29, 30, okay, I think that's reasonable. Let's cool it down a little, oh no, increase it a little more to it's in the 20, or below 25 at all times. Let's do something like that. So, there we go. So, yeah, I think, okay, there we go, perfect. Alright, so, looks good. So now we're on the last one, which is probably the greatest challenge of all, is Planet 9. Because this is going to be very, very difficult to make sustainable and like stuff. Because if you look at its orbit, it's going to have a very close point to the sun, and then this side, in the complete darkness, it's going to be freezing. I don't know if I'll be able to do anything about that, but I'll give it my best shot here. So let's put it at, I don't know, so let's have it at the closest point to the sun. So let's go to the anomaly here. So this is the closest point Planet 9 is to the sun. So now let's put an atmosphere of 1,700 or 600. And as you can see, it has a custom coloured atmosphere because it was a custom planet. So it's still completely like in darkness like this, because no matter where Planet 9 is, it's still in darkness. So there's never going to be any daylight here unless we change the sun settings. But we're not going to do that, otherwise it will mess up all the other ones. So we've got to somehow make this planet habitable. So let's put it at 0. Now, will it increase? So it still gets cold even at 1600 ATM, which is ridiculously crazy. Can we... Wow, okay, 2000, mate, this is crazy. Still getting cold, like, and this is at its closest point. Is this even possible? Like, we could have a an Earth-like planet close by to make it. Let's try Kepler 22b, for example. So, or something of a similar size. So, okay, Kepler 22b is too. Okay, so something like this, because I don't know how else this is going to work. So, let's put it in a binary and put them really close together. Will this warm it up or not? So let's speed up. Is it gonna... Why is the tidal heating not work? That should be warming the planet up. What about this one? Is this heating up? It's still minus... What? Let's try 0 again. Will it reset? Have we got tidal heating enabled? I'm pretty sure we do. So... I have no idea what to do here. If anyone can help me colonize Planet 9 without using tidal heating, please tell me. Or with tidal heating, I mean. I think it's on performance, like... I have no idea what I'm clicking on here. I don't go into these settings much. Debug, maybe? Is there anything on that? I can't see anything. No, I can't see it. I'm sorry, guys. I have no idea. So, I don't know anything about the tidal heating. It should be working. Like, if we put a planet like... Let's try Mercury, for instance. Like a regular Mercury. Put it really close and hit play. It should get torn up, I want to say. So, yeah, there we go. But is it going to warm this up? Like, we can have some of the fragments land on the surface, but is it really going to do anything? Let's delete them. It doesn't seem to be doing anything. Like, we can... Like, please? Like, it's still getting colder. No matter what you do, it's still getting colder. Wow, okay, so we're going to have to make this crazy. Let's try 10,000. Will this warm it up? No, it still isn't. Well, if we make it absorb all the light it receives. Still getting colder. We have the infrared efficiency on max. No magnet. It's had a bit of a magnetic field. Okay, that's way too high. So 0. Let's do 0.7 maybe, like that. We don't really want to play with that too much, but we're not going to get much radiation from the sun here anyway. But honestly, let's try 100,000. Is it like a million? Like, it's still getting colder, and it's its closest point to the sun. Wait, how many zeros is that? So wait. 10, 100,000, 10,000, 100,000, million, 10 million, 100 million. Please work. Still getting cold at 100 million ATM. 1 billion? 10 billion? Please, 10 billion? Pressures of Earth. It's getting too big now. Okay, so I'm gonna have to say I don't know for this. Like 0. Like it still won't heat up. Like. And then this is its closest point to the sun. Like, what if it's its furthest point? Like, if it's not even orbiting the sun anymore. I don't know what's probably inside that second planet, but damn it. Well, now That does suck. Like, we can make it orbit again so it's like a normal orbit. Like, we can try that, but it's still not working. Dang it. 20. Like, we can warm it up, but we can't really do anything. So, Planet 9 is probably going to be known as the ice or the ice ball because we can't really do anything with it. Like, we've tried everything. Like, we can make this option bigger here. Like, the surface pressure is getting way too big. ATM. Like, what if we try the atmosphere mass of the one sun? Like, is this going to blow it up or is it going to warm up? It's still getting colder, and it absorbs all of the light it receives. What about 100 suns? 1,000 suns? 10,000 suns, 100,000 suns, a million suns, I don't know, that amount, or whatever this is, I don't know, like, it won't get any higher than that. We've got the maximum amount of atmosphere mass, and it's still getting colder. Like, let's just put it up to, let's burn it for its bad behaviour, so let's put it up to 2,000 degrees, bad Planet 9, I don't know, it's not working. Is it going to heat up? There we go, yeah, get tortured, you deserve it. You've messed this up. Okay, so I don't know what to do here. So I think this is the end of the episode, guys. So, yeah, let's make sure. Okay, what happened here? Venus, what are you doing? I have no idea what's going on here, guys. I have no idea why it's doing this. So, let's put it back to what it... Why has it got further away from the sun? Let's decrease that. It should be... No wonder it's all messed up. What is going on here? Okay, so, yeah, we did do it. We colonised all the planets apart from Planet 9 for some reason, so Mercury's... Why is Mercury getting hotter now? What is going on? We're only 3,000 years into the future. The sun's not going to be that hot. Okay, that's very strange. But anyways, let's pause this for now. I'll sort this out at my own time. If I do a part 2, I'll make sure it's all working perfectly. But yeah, there we go. So yeah, Planet 9's been naughty. So we got our jungle Jupiter, we got our tropical Saturn, we got our mountain Uranus, we got our ocean Neptune, we got Earth obviously, then we got Venus. I don't know what to name this. Desert Venus maybe, since it's more of a desert sort of colour. Oh no, Mars is the desert. So desert Mars. Let's just call it, I don't know, hot Venus still, and then we got small Mercury or tiny baby Mercury. I don't know. But anyways, there we go. So that is that. So we have done it. We did colonise all the planets there at some point. I don't know why Venus and Earth and Mercury have gone all crazy. So I'm really impressed or happy with the Saturn and Uranus and Neptune, and especially Jupiter as well. The jungle Jupiter's pretty cool. But yeah, that is that. So this is a long episode for our double upload today. And Planet 9 is a very, very bad planet. But yeah, there we go. So hopefully you all enjoyed this very, very long episode and crazy episode, I should say. And yeah, should I do a part 2 with Ceres, like Pluto, Eris, Sedna's going to be a problem, and then Planet 9. If anyone can help me with Planet 9 colonising it, please tell me, because I have no idea what to do. I may look up on how to do it, because like we could try a black hole or something. I have no idea. But anyways, I think that is everything. And also, quick update, we are so close to 300 subs now. We're like less than 20 away right now, I believe. Yeah, we're at 280 something. So yeah, we are closing in fast. So we are definitely going to hit the goal before the end of the month. We have 11 days left, and we are zooming to 300. So yeah, so if you haven't subscribed already, make sure you hit that subscribe button, because yeah, this is pretty awesome. We are doing pretty well here. So yeah, I think that's everything I needed to say. So yeah, so make sure you hit a like, subscribe if you're new, help us on the road to 300, and yeah, if you've got any ideas on how to help me do Planet 9, please leave a comment down below, because I have no idea what to do, and should I do a part 2? Right, that's everything. Anyways, I'll see you in the next video. Goodbye.